Hello Year 11 and welcome to today's lesson. There are two parts to this lesson. The first is what everyone needs to do, which is the 4 gas tests. And then later on it will only be for the separate sciences where we're looking at ion testing as well. So we're going to start off with the gas tests, and there are 4 gas tests that we do have to know about. We need to know the test for hydrogen, oxygen, carbon dioxide and chlorine. We need to know how to do the procedure, and we also need to know what a positive result would look like. So in order to get all the information in a nice concise way, I've created a table that I'd like you to copy. You can see that it's got the 4 gases going along the side. There'll be space for a description of a test. This will be your largest column, and then what a positive result would look like. So if you could pause this video and complete that table, please. Okay, so hopefully we've got our table ready to go. So we're going to go through the 4 different gases, how we test for them, and what a positive result is. So we're going to start with hydrogen. Now, hydrogen is one that you would do at key stage 3. Very, very simple test. You would take a lit splint. You would put the lit splint into your sample of gas, and because hydrogen combusts very quickly, it will cause a pop sound. So for our description of how to do hydrogen, it's put a lit splint into the sample of gas. A positive result would be a pop sound. So pause the video now and complete that section of your table. Okay, so our next gas is oxygen. Again, oxygen does come up in key stage 3. You would have done it in GCSE as well. Very simple procedure again. This time you take a lit splint and you blow it out, and that will give you a glowing splint. And then you would put that glowing splint into your gas sample, and if the gas is oxygen, it will relight the glowing splint. So the procedure of how to do it is light a splint and blow it out, put the glowing splint into the gas, and the positive result would be the glowing splint will relight. So if you pause the video now and get that into your table. Okay, so our next one is carbon dioxide. Again, carbon dioxide comes up at key stage 3. You will have done this one before, seen this one before. You would use something called lime water, which is calcium hydroxide. And what you do is you bubble your gas through lime water, and if the lime water goes cloudy or milky, then it is carbon dioxide. So the procedure is to bubble the gas through lime water. A positive result would cause the lime water to go cloudy or milky. So pause the video now and add that to your table. Right, our final gas test is for chlorine, and for chlorine we use some damp blue litmus paper. And what you do is you put the damp blue litmus paper in your gas sample, and if the gas is chlorine, it will bleach or turn the damp blue litmus paper white. So the procedure is put damp blue litmus paper into your gas sample, and a positive result would be bleaching the damp blue litmus paper. So if you could pause the video and finish off your table with the gas test of chlorine. Okay, so if you are in any of the classes apart from G1 and G2, that is it for the gas test, or the test that you need to know for combined science. So please use this time to go over your notes over this week and create a revision map of chemical analysis so far. You've got another lesson with Miss Slade tomorrow, where she's going over the required practical, which is the chromatography practical. So you can add that to your revision map when you are done. If you're in G1 and G2, we're going to continue where you need to know about ion testing as well. So if you are doing the separate sciences, then we need to know these tests. So we need to know about flame testing, we need to know about precipitate reactions, we need to know how to test for carbonates, chlorides and sulfates, and we also need to know an instrumental technique and the advantages of instrumental techniques. So we're going to start off with flame testing. We've got a picture here showing some flame testings. So I'd like you to think to yourself, what type of ions can be identified using flame testing? So what do we use flame testing for? So hopefully you have put down, or you thought that it is for metal ions or cations. And there are 5 different metal ions that we need to know what happens when you flame test them. So what colour the flame goes. So I've written down the 5 metal ions that you need to know, and we're going to complete the colour of the flame. So what I'd like you to do is pause the video, make this table in your notes, and before you move on to get the answers, I want you to see if you can remember any of the colours that the flame goes for any of those 5 metals. So pause the video and make your table now. Okay, so hopefully we've got our table done, and hopefully we've had a guess at some of the colours of those metal ions when they undergo flame testing. Here are the ones or the colours that we need to be able to say from the specification. So lithium will turn the flame crimson, sodium will turn the flame yellow, potassium will turn the flame lilac, calcium will turn the flame orange-red, and copper will give a green coloured flame. So we use flame testing to test for metal ions or cations. And these are the 5 metals that we need to know what colour the flame goes. So now we're going to move on to our next test, and this is looking at metal hydroxides. So I've got a picture here showing some positive results. So I want you to think about what is happening, how is it that it identifies the cations, and do you know any of the ions present? So from those 3 colours, do you know what the ions would be? So pause the video and have a think about the answer for those 3 questions. Okay, so what is happening here? This is something called a precipitate reaction. So when you introduce metal hydroxides to other chemicals, it causes a precipitate reaction. And that's where you are forming a soluble substance from 2 soluble solutions. So you can see in the picture that you're getting some solid kind of like jelly being produced. So we can use these precipitate reactions to test for ions, the cations in metal hydroxide. So we can test for the metal in a metal hydroxide. How does it identify the cations? So say it's producing a precipitate reaction, and depending on the colour of the precipitate will tell you what ion is present. Now the ones that we need to know, and 3 of which, the bottom 3 were the ones from the picture, we've got 6 different metal hydroxide. What you do is you add the metal hydroxide to sodium hydroxide, and if a precipitate forms, then you can look at the colour of the precipitate and determine what metal was in the metal hydroxide. So here are the 6 ions in the solution. So we've got aluminium, calcium, magnesium, copper 2, iron 2, and iron 3. Now the brackets with the numbers in the middle of them shows what ion it forms. So that's a copper 2 plus ion, an iron 2 plus ion, but iron can also make a 3 plus ion. Now, if you add sodium hydroxide to aluminium, you form a white precipitate. But if you keep adding sodium hydroxide, that white precipitate will actually dissolve, which is different to the next two, which form a white precipitate. Calcium will form a white precipitate, and magnesium will also form a white precipitate. So it's very hard to distinguish between those three, because all of them are going to form a white precipitate. Three that do make interesting colours is copper will form a blue precipitate, iron 2 will form a green precipitate, whereas iron 3 will form a brown precipitate. So this is using precipitate reactions. This is how we can test for these metals in a hydroxide by adding sodium hydroxide to it and looking at what colour precipitate is formed. So can you pause the video and pop those precipitate colours and the ions down, please? Okay, so we're going to look a little bit more about precipitate equation, precipitate reaction. So here I've got a solution of iron chloride, and I'm reacting it with sodium hydroxide, and it forms a solid precipitate, which would be iron hydroxide, and it will be in a solution which would be sodium chloride. Now, if I was looking at this in front of me, the iron chloride is a yellowy brown solution, and sodium hydroxide, which you would have used before, is a colourless solution. So you'd have a yellowy brown solution, a colourless solution, but there'll be no solid present. If you react those two together, you'll form a brown precipitate, so that will be the brown solid, and that will be in a solution which would be sodium chloride, which again is a colourless solution. So what I'd like you to do is pop down that symbol equation, and I'd like you to add state symbols to each of those compounds, and I'd also like you to have a go at balancing that equation. So pause the video and do that now, please. Okay, so hopefully we've had a go at that, and we will have that we have iron chloride solution, so that will be AQ as the state symbol, sodium hydroxide solution, so that will be AQ as the symbol. We've got iron hydroxide, which is a precipitate, so very important to remember that that is a solid, and then that will be in sodium chloride solution, so AQ again. Now if we're going to balance it, in order to balance out the hydroxides, we'll need a 3 in front of the NaOH, so that we've got our 3 oxygens and 3 hydrogens. And we would need a 3 in front of the sodium chloride, the NaCl, so that there are 3 sodiums on each side. And that would also balance out the chlorines. So that is a balanced symbol equation with state symbols of a precipitate reaction. So we just need to remember that you have 2 solutions and it forms a solid and a solution. Right, so that was looking at positive ions or cations, looking for metals. So you've got flame testing and also doing precipitate reactions. So what we're going to look at now is how we can test for the negative ions. And our first negative ion is carbonates. So carbonates form a CO3 2- ion. Now, can anyone remember how to test for carbonates to see if something contains a carbonate? I've put a picture and blocked out the descriptions, the annotations for the picture. So just give yourself 10 seconds to have a go at trying to remember how you can test if something contains a carbonate. Okay, so hopefully we've realised that we've got a reaction happening on the left-hand side. So our possible metal carbonate in there, and it's reacting with a liquid. There is a delivery tube, so it's forming a gas. It's a delivery tube going into another liquid that is testing for that gas that is starting to go milky. Hopefully we realised that what we can do is take our substance and react it with dilute acid. It can be any acid, but it needs to be a dilute acid. And that will form a gas. Do you know what gas is being produced? Hopefully we realise that it's going to be carbon dioxide gas. So if we pass it through lime water, then it will go milky or cloudy. So to test if a substance contains a carbonate ion, is we would react it with dilute acid, and if it turns lime water cloudy, it means that it's created carbon dioxide, so was a carbonate. So we're next going to look at halides. Halides are the halogens, which is group 7. So you have a halide ion, and examples are chlorine, iodine, bromine, etc. So how can you test to see if a substance contains halide ions? Do you remember how to do this test? So the three that we need to know are chloride ion, bromide ion, and iodide ions. And what you do is you react it with dilute nitric acid, and that just gets rid of any carbonates that might be present in the substance. You then add silver nitrate, and if it forms a precipitate, then a halide is present. So add dilute nitric acid, add silver nitrate. If there's a precipitate, then a halide is present. And the three precipitates that we need to know are for chloride ions, bromide ions, and iodide ions. Chloride ions will always form a white precipitate. Bromides will always form a cream precipitate. And iodides form a pale yellow precipitate. So if you add dilute nitric acid and then silver nitrate, if it forms a precipitate, it contains halide ions. And if that precipitate is white, it's a chloride ion. Cream, bromide ions, and pale yellow are iodide ions. So we're next going to look at sulfates, or SO4 2- ions. Does anyone know how you can test for a sulfate ion? So if a substance contains sulfate ions. You might have a clue from the picture because it's looking like a reaction that we've looked at before. So if you want to see if a substance contains sulfate ions, then this time you would add dilute hydrochloric acid, and then you would add barium chloride. And if it forms a white precipitate, then it contained a sulfate. So the steps are add hydrochloric acid, dilute hydrochloric acid, then add barium chloride, and if it's a white precipitate formed, then it contained sulfate ions. So those are the tests that we need to know. The flame testing for cations, the precipitate reactions for cations, the carbonate test for negative carbonate ions, the precipitate test for halide ions, and also the precipitate test for sulfate ions. What we can also do is use instrumental methods. So these are methods that will be done in industry to look very, very accurately at what is inside different substances. So it won't be a simple colour change, which is very easy to get wrong if it is contaminated. So you can use big instruments that will give you a much more accurate result. They're also a lot more sensitive, so that you can use a lot smaller amount of it. If any of you ever watch the Border Force programs, you'll see that they do swabs and they put it into a machine. That machine will be looking at the ions that are present to see whether it contains explosives or drugs and things like that. It's also considerably faster using instrumental methods, so using machinery to do it, compared to taking all of the substances and reacting them with specific amounts of specific chemicals. So you need to know some ways in which instrumental methods are better, the advantages of instrumental methods over using simple laboratory methods, which are the ones we just went through. So they are more accurate, more sensitive, and they are faster. Now there is one that you need to know in a little bit more detail, and that is flame emission spectroscopy. So it's kind of like a really advanced flame test. Now please do not copy this diagram. It was the simplest one that I could find on Google Images, but it's still more complicated than what you need to know. The bits that I've put at the top, the descriptions, that's the important part. So you'll have your sample, and basically you put the sample into a flame. The light from that flame will pass through some lenses and filters until it reaches something called a spectroscope. Okay, a spectroscope. And a spectroscope is a piece of machinery that will be able to pick out the individual wavelengths created in the light. So what you end up with are spectroscopes, picture images that look like this. So you can see that all of the different metals that are listed on the left hand side have a very individual image that's created by the spectroscope. So if you were working with calcium, for instance, and is rubidium on there? Yeah, rubidium. Both of them will turn a flame red. So sometimes it can be quite hard to distinguish between them. So if you use this method, you will get this individual image. So it's a lot more accurate at determining which metal is in it. You can see at the bottom you've got the nanometers, that's the wavelengths of the light that is emitted from the flame. Here is a slightly different way in which it's shown. So here we've got our two flames, it's probably sodium and lithium. Yep, in fact it says lithium and sodium on there. And you can see that on this image, instead of it having the light spectrum, it's got a graph that just shows you where the peaks are of that wavelength. So that is flame testing spectroscopy. That is one instrumental method that we need to know about. And we also need to know those three advantages of using instrumental methods, which are it's faster, more sensitive, and much more accurate. So that is it from me. So thank you very much. I appreciate that that is longer than the combined science ones, but this is the additional content for the chemistry. So make sure that you know all of those different tests, both the gas tests and the ion tests. On Friday there won't be questions on the ion tests, but you can find questions in your revision guides. So if there's any part that I've gone through that you're unsure about, please make sure you have a look at your revision guide, and that will hopefully clarify it. If not, please feel free to email me as well. Right, well, I hope you're enjoying the snow. It's Monday today, so it's still pretty snowy for me. I don't know if it's still going to be there for Wednesday, but if it is, go out and enjoy yourself, and you'll have Miss Slade tomorrow. Thank you very much, and goodbye.